Today we will discuss general characteristic of organic compounds. You know that organic compounds may be hydrocarbons and derivatives of hydrocarbons. Hydrocarbons are those compounds which are composed of only carbon and hydrogen. And the derivatives of hydrocarbons may contain oxygen with carbon and hydrogen. They may contain nitrogen, phosphorus, sulfur, halogens, fluorine, chlorine, bromine, iodine. They may be the members of these derivatives of hydrocarbons. Hydrocarbons, they are non-polar. The electronegativity difference between carbon and hydrogen is very small. That's why their covalent bonds will be non-polar covalent bond. We have two types of covalent bonds, polar and non-polar. If the electronegativity difference is less than 0.4 between two bonded atoms, if it is 4 or less than 4, then such bond will be non-polar. These derivatives of hydrocarbons, they are polar compounds. Oxygen is electronegative, or we can say highly electronegative. Nitrogen, phosphorus, sulfur, halogens, their electronegativity is always greater than carbon. So, due to their presence, the molecules or the bond will be polar covalent bond. Then we have some common characteristic of organic compounds. How we will come to know that this compound is organic or inorganic. We have two types of compound, organic. For organic, we have studies that those compounds which contain carbon and hydrogen, they are called hydrocarbons and the derivatives of hydrocarbons. The rest of the compounds, they are inorganic compounds. They are inorganic compounds. So, the composition means that a compound will consist of carbon hydrogen or carbon hydrogen and oxygen, carbon hydrogen and nitrogen. This is called composition. Why the characteristics are common in organic compound? Because their molecular structures, they are very close to each other, or we can say they are similar. That's why they have some common characteristic. Number one, composition. So most of the organic compounds are composed of hydrocarbons, compounds of carbon and hydrogen. And along with hydrocarbons, we have derivatives of hydrocarbons. And I told you that they are non-polar in nature. The next thing is that carbon is non-metal. Carbon is non-metal. A hydrogen is non-metal. If two or more than two non-metal atoms chemically combine together, they always form covalent bond. So the next characteristic of the organic compound is covalent nature. Covalent nature means that organic compounds are composed of non-metals. Carbon is non-metal, hydrogen is non-metal, oxygen is non-metal, nitrogen, phosphorus, sulfur, chlorine, bromine, they are all non-polar. And if they have deficiency in their valence shell, so they can obey octet or duplet rules by sharing of electrons. So all organic compounds have same nature, that they have covalent nature. We can take the example of carbon and hydrogen, a hydrocarbon. This is the simplest hydrocarbon, one carbon with 4 hydrogen. Its name is methane. So carbon has 4 unpaired electrons in its valence shell, and it combines with 4 other hydrogen atoms, and this is called sharing of electron. So this is covalent bond. This is covalent bond, single covalent bond. One shared pair represent one single covalent bond. So we can also write it like this. I will represent it like this. This is tetrahedral shape of methane. And same is the case with all hydrocarbons. In hydrocarbons, we have discussed alkanes, alkenes, alkynes. They were open chain, straight chain, branched, they were closed, they were saturated, they were unsaturated. But bonds were covalent bonds. So their nature, covalent nature, all organic compounds are having covalent bonds between their bonded atoms, whether they are carbon hydrogen, they are carbon hydrogen and oxygen. This is an example of carbon, hydrogen and oxygen. This is the derivative of hydrocarbon, this is oxygen. It has 6 electrons in its valence shell, and now it has completed its octet. This one has completed its duplet. Each hydrogen has completed duplet. Each carbon the carbon has completed its octet. Oxygen octet rule has been applied on it. So this is the covalent nature of organic compounds. Then we have another property which is solubility. Solubility. Now we will check their solubility, whether they are soluble in water or insoluble in water. We use water as a universal solvent, and we check the solubility of substances in water. So this is important that hydrocarbons, those compounds which are made up of carbon and hydrogen, they are called hydrocarbons, and they are non-polar. As I have told you that they are made up of carbon and hydrogen, and the compounds which are made up of carbon and hydrogen, they are non-polar. And we know that water is a polar solvent. In water, we have hydrogen and oxygen. Oxygen is more electronegative than hydrogen. It attracts the shared pair of electrons more towards itself, and partial negative charge or slight negative charge appears on oxygen, and partial positive charge appears on hydrogen. It is polar. And there is a rule, like dissolves like. These hydrocarbons and water, their nature is not same. How? They are non-polar and water is polar. And we have the rules or the principle like dissolves like. So they are unlike, therefore they all are insoluble in water. For hydrocarbons, we can say that they are organic compounds and they are insoluble in water due to their non-polar nature. Next, we have derivatives of hydrocarbons. The derivatives of hydrocarbons, as I mentioned earlier, that they are polar. But majority of organic compounds are hydrocarbons. So they are polar, these derivatives of hydrocarbon, and water is also polar. Therefore, like dissolves like principle says that polar can dissolve polar. If we are having this compound C2H5OH, this is alcohol. This is ethanol, or this is ethyl alcohol. and it is soluble in water. Why? Because it is also polar. Partial positive charge on hydrogen and partial negative charge on oxygen. It makes ethyl alcohol a polar compound, and water is also polar. Therefore, it is soluble in water. Hydrogen bonding is present in water as well as in ethyl alcohol. Therefore, they are soluble, or alcohols are soluble, but lower member of these alcohols are soluble in water. If we have CH3OH, C2H5OH, they are soluble in water. The rest of the alcohol, if they are having long chain of alkyl radical, then they are very slightly soluble in water. So this is about the solubility. So we have discussed the composition of organic compounds, that they are composed mainly of carbon and hydrogens, and they are called hydrocarbons. They are non-polar. Then we have polar, and they are derivatives of hydrocarbons. Why they are polar? Because some elements which are like oxygen, nitrogen, and halogens, they are highly electronegative, and they make the molecule polar. Then we discuss the covalent nature. Why they are having covalent nature? Because all organic compounds are made up of non-metals, and non-metals, when they complete their valence shell, they do so by sharing of electrons. So carbon is non-metal, hydrogen is non-metal, so all hydrocarbons are covalent in nature. They have covalent bonds. Similarly, the derivatives, they also have covalent bond. Then the solubility depends on the nature of solute and solvent. The substance which will dissolve is called solute, and the substance which can't dissolve substances, that is called solvent. We check the solubility of substances in water, and water is a polar solvent. If we will try to dissolve hydrocarbons in water, they won't, because they are non-polar and water is polar. Their nature is unlike. The derivatives of hydrocarbons, they are polar, and due to their nature, same nature as water is polar and they are polar, polar dissolve in polars. Therefore, like dissolve like principle can be applied on polar derivatives of hydrocarbons or organic compounds. I have given an example of alcohol. This is an alcohol. It is derivatives of hydrocarbon. This is another alcohol, and it is also derivative of hydrocarbon. Polarity is here. When hydrogen is covalently bonded with oxygen, if it forms a covalent bond with oxygen, so partial positive charge will appear on hydrogen and partial negative charge on oxygen. This is a polar substance and it can dissolve in water. This is all about the solubility. So today we have discussed three properties, general characteristics of organic